Hi class, this podcast has to do with trends, and the trend that we're going to talk about in this podcast is size. And usually the way this is structured in books is atomic radius. Alright, so trends is simply going to be atomic radius. And we can kind of think of atoms being circular in nature. So radius is simply from the center to the outside, alright, and just think of it as a circle. So really, atomic radius, that simply has to do with size, alright? So there are two trends we can find as we go across a period or down a group, okay? So we're just going to draw some pictures and kind of see what this looks like. So if we start with hydrogen, let's say, hydrogen consists of a 1s orbital, and for now I'm just going to say s orbitals are spherical. When we think of electron clouds, we think of them as spherical anyways, but it has a size about like that. Whoa. Has a size about like that. And it is a sphere, not just a circle, so I'll try to make it a little bit spherical. As we go down to, let's say, lithium, it's a 2s, and the energy level has to do with size. So it's still a sphere because it's an s, but it's a bigger size. As we go down to 3s, with sodium, we have an even bigger sphere, alright, 4s on down. So one of the trends we can see is the group trend, and groups are columns. So you might put in your notes groups/columns, but from top to bottom, so I was going to say from top to bottom, size increases. Right? So groups, as we go from top to bottom, size increases. It does not matter what group we're in. We were kind of talking about alkali metals. The same thing would be true of halogens. It's a group trend. Okay? So the next thing we need to talk about is a period trend. So I'm actually going to write it above this. So periods. So periods are going from left to right, or periods you might think of as rows. So groups are columns, periods are rows. So as we go across a row, we want to know what happens. Alright? So two things happen. As we go across, we are adding two different things. Specifically, we're adding protons, alright, because in order to go from left to right, our atomic number is getting larger. And if we're adding protons, we're necessarily adding electrons. Okay? So, when we go from lithium to beryllium, okay, lithium has 3 protons, and beryllium has 4 protons. Lithium has 3 electrons, and beryllium has 4 electrons. So I'll just tell you the trend first. From left to right, size decreases. You might go, well, that makes no sense at all because we're adding stuff. Alright? So here's the rationale for it. As we go from left to right, we are putting all of our electrons in the same energy level. Okay, so they're having to go in that same spherical electron cloud. They're all getting the same area because it's the same energy. Okay? However, what's happening in the nucleus? Well, in the nucleus, in the center of that electron cloud, we're adding more and more protons. So think of it as our magnet in the middle is getting stronger and stronger and stronger. So what is that magnet going to do to the electrons around it? It's going to attract them more strongly, and that is going to decrease in size. Alright? So we might draw beryllium. It's not a whole lot smaller, but a little bit smaller. How come? Because these 4 protons are in the nucleus, and the magnet's getting stronger, so they're attracting those electrons more tightly to themselves. As we go from there across, over to boron, there's kind of this big gap here, but as we get to boron, we have 5 protons, still attracting 5 electrons, but all those electrons are in the same area, so our magnet's going to be stronger, so they're getting smaller. So again, trend for size. If we were to draw the periodic table, kind of real quickly, kind of something kind of like that. Alright, I'm just going to put up here, smallest, and then down here we have largest. So from top to bottom, they get larger. From left to right, they get smaller. Okay? and that is the trend for size.